let's take a look at z-scores. So by definition, for a probability distribution with a mean of mu and a standard deviation sigma, the z-score, also called the standard score, of a particular data item is just the number of standard deviations away it is from the mean. So for example, let's consider a normal distribution with mean, how about 100? So mu is equal to 100. And our standard deviation, let's say, is sigma is equal to 5. And suppose we want to find the z-score of a data item of how about 110. So we're going to find the z-score of x equals 110. And well, if we think about it, we have to look to see how far away is x from the mean. And well, we can see that it's 2 standard deviations above the mean, right? 110 is 2 times 5 greater than the mean of 100. And so here we would say that the z-score of our data item is 110, so this is just this notation lets us know that we're finding the z-score of 110, and we see that it's 2 standard deviations above the mean. So its z-score is 2. Okay. Similarly, actually it's the same example. Let's now find the z-score of a different data item. Let's find the z-score of x equals about 95. Okay, so we're going to find the z-score of 95. And well, now we can notice that 95, well, that's just 1 standard deviation below the mean, right? Because that's 100 minus 1 standard deviation of 5. So here we would get, and because it's below the mean, our z-score is actually -1. So one thing to keep in mind, if z-score of x is positive, then we know that x is greater than mu. It's greater than the mean, right? Whereas if our z-score of x is negative, right, like in the second example, well then x is less than the mean, mu. Okay, so that's just something to keep in mind. A z-score can be either positive or negative. If it's positive, then your value is above the mean, and if it's negative, then your data item is below the mean. Right? Well, now, how do we find the z-score kind of in general? So we're going to come up with a formula for finding the z-score. Right? So to find our z-score, so z of x, well, first we have to figure out how far away is it from the mean. So we're going to take our data item x, and we're going to subtract the mean. That gives us our distance. Well, now we have to figure out, well, how many standard deviations is that? Like, for example, up here, if we did our x value of 110 minus 100, that gives us 10, but how many standard deviations away is that? Oh, well, standard deviation is 5, therefore that's 2 standard deviations away. So what we have to do is we have to finish by dividing by that standard deviation. We're going to divide by sigma. And there we go. This is our formula for the z-score. So let's take a look at another example. So example 2, let's suppose we have test scores that are normally distributed, the mean is 75, and the standard deviation is 8. Let's find the z-score of a test score of 87. Okay, so just to kind of identify everything here, our data item that we're looking at, our x value, is 87. Okay. And our mean mu is 75, and our standard deviation sigma is 8. Right? And so using our formula for the z-score, which again is the z-score of x is x minus the mean divided by the standard deviation. And what we're going to get is 87 minus 75, and we're going to divide that by 8. Which this comes out to, let's see, 87 minus 75 is 12 divided by 8, and this is equal to 1.5. So what this means is that the data value 87, a test score of 87, so let me just write this, a test score of 87 is 1.5 standard deviations above the mean. And we know that it's above the mean because our z-score is positive. If our z-score was negative, then we would know that it would be below the mean. Right. Let's take a look at part B. So now we're told that a test score has a z-score of 2.3. So we're given the z-score, and what we have to do is find the original test score, or the raw score. Okay. So now what we're given is z, and our job is to find x. That's what we mean by finding the raw score. Okay. So how are we going to do that? Well, let's take a look at our formula again. Remember, our formula for z-score is z is equal to x minus mu over sigma. Okay. And our job is to find x. So what we need to do is solve for x. All right, so what can we do first to solve for x? Well, maybe I can start by multiplying both sides by sigma in order to clear my denominator. So I'll multiply both sides by sigma. Right? When we do that, the sigmas on the right-hand side cancel, and what we're left with is, let's see, I have sigma times z is equal to x minus mu. And now to finish solving for x, all I have to do is add mu to both sides. So what I'll have is sigma times z plus mu is equal to x. Or if you like, this is a nicer way to write it, x is equal to mu plus z times sigma. Right. Okay, so now let's apply this to part B, to answer part B. So we want to find the raw score, or the x value, when our z-score is equal to 2.3. So if we use our formula, well, what is mu again? Mu is, up here, 75. Plus our z-score of 2.3 times the standard deviation, which again is 8. And if we do this calculation, 75 plus what is 2.3 times 8, that's 18.4. And what we get is a total of 93.4. So this here is the test score. And there we go.